If you put it where the sun is, it would extend to Jupiter's circle. This huge, genuinely unsound event will produce more energy than 1 billion suns combined. These explosions are among the most powerful radio energy explosions in the universe. Are you prepared for the upcoming events involving Betelgeuse, one of the closest red supergiant stars to Earth? It has recently been noticed that it has dimmed quite a bit, which has got people talking and got mixed reactions worldwide. People who study the universe and the general public have been wondering what this darkening might mean. Some scientists think this unexpected behavior might be a sign of a cosmic explosion, which is when a star runs out of atomic fuel and collapses under its own weight, producing a tremendous blast. The general public and mainstream scientists are both concerned about such an occurrence, since it raises questions about what it might mean for our own planet. Betelgeuse is a distinctive star cluster that's easy to spot in the night sky thanks to its unique form and bright stars. It's the largest and brightest star in this constellation and is also known as Alpha Orionis. NASA's Hubble Space Telescope and other observatories have recently observed a significant increase in mass around Betelgeuse. This behavior is of interest to astronomers worldwide, as it is unusual for a star of this kind. What we know about how stars live and move is stronger thanks to what we've seen in Betelgeuse. Even though coronal mass ejections are pretty common in our own sun, there's still some disagreement among astronomers over how far away Betelgeuse is from Earth. Some think it's further away, while others say it could be as close as 724 light-years. Red supergiant stars like Betelgeuse are tricky to measure accurately in distance because they're so big and have such unique characteristics. As one of the brightest stars in our night sky, Betelgeuse is several times brighter than the sun. The downside to all this brightness is that it speeds up the rate at which Betelgeuse uses up its fuel, which means it will run out sooner than usual. When that happens, it will collapse under its own gravity, which could cause a cosmic explosion that might produce a black hole or even a neutron star. This raises an important question. Could Betelgeuse pose a risk to Earth? If our current astrophysical theories are correct, a cosmic explosion just a few hundred light-years from Earth could have a devastating impact. A supernova is an incredibly bright event, potentially as bright as a whole galaxy. So even though Betelgeuse is relatively far away, like the star Alpha Centauri, the consequences of its cosmic explosion could be significant. It's surprising that we haven't seen a local cosmic explosion since the last one was observed in our own galaxy in 1604. But in 1987, there was a significant cosmic explosion in the Large Magellanic Cloud, which is 169,000 light-years away. That event served as a reminder of the scope and possible significance of such cosmic phenomena, even though it had enormous impacts and didn't directly endanger Earth. The idea of a danger zone around a normal cosmic explosion is fascinating. If a supernova were to happen close enough, it could have a significant impact on life as we know it. It's important to remember that gamma-ray bursts are much more powerful and pose a different kind of risk than nearby supernova, which are relatively minor events. Gamma-ray bursts can have devastating consequences, killing biospheres and covering planets with deadly radiation. For example, a specific type of cosmic explosion could destroy a planet's ozone layer, leaving it exposed to space radiation long after the blast has occurred. A recent study that highlighted new potential hazards related to massive stars that die in such a dramatic way brought attention to this issue. Some of the brightest lights in the universe can be reached by massive stars exploding in a supernova. The brightness of a single supernova can really outshine that of billions of stars. This raises the question of what the consequences would be of such an explosion in Betelgeuse. If Betelgeuse were to undergo a supernova, it would become the second brightest object in our sky after the sun. It's pretty amazing that even though Betelgeuse is so far away from us, it would still be visible during the day because it is brighter than a full moon. Even in the dark, the explosion would be so big it would create shadows. A picture like that would show us just how powerful cosmic events can be. It would be pretty amazing and also pretty scary. While the visible light released by a supernova is pretty impressive, it only represents a small portion of the energy generated during the event. While high levels of visible light can temporarily impair vision, it's the high-energy radiation released along with it that's more dangerous. This radiation often takes the form of gamma and X-rays, which can have serious consequences. One of the biggest threats is the potential of this high-energy radiation to accelerate the depletion of the ozone layer, which shields our planet from dangerous solar radiation. If we didn't have a strong ozone layer, the intense UV radiation from the sun would expose life on Earth's surface to serious risks over time, including mass extinction events. Cosmic rays and subatomic particles, moving at almost the speed of light, start to invade the solar system. But the aftermath of a supernova can be pretty dangerous too. These massive beams can increase the risks caused by the initial explosion, which could destroy ozone layers and cover the Earth's surface with dangerous radiation. We've found elevated levels of iron-60, a radioactive isotope created in supernova, in seafloor sediments and lunar regolith. This is evidence that such occurrences may have impacted Earth in the past. This discovery suggests that supernova may have affected Earth in the previous few million years, or even more recently. Given what we know about the dangers of cosmic rays and gamma rays, astronomers have previously said that there are currently no supernova that pose an immediate threat to life on Earth. However, ongoing studies have identified some new potential dangers linked to specific types of gamma ray bursts. These gamma ray explosions are more dangerous to planets like ours because they can emit deadly radiation over vast distances. This is down to the fact that a star that's nearing the end of its life is surrounded by a large disk of material. The disk is hit by the shock wave from the supernova, which makes it really hot. Lots of high-energy X-ray radiation is produced as a result and can travel a long way through space. The ozone layer of a planet could be reduced by up to half by the most intense X-ray supernova, which could lead to an extinction event within 150 light-years, on average. Fortunately, there are no known supernova in nearby galaxies that could potentially affect Earth. This research has also helped us to understand the cosmic habitable zone better, which is the area of galaxies where conditions are right for life. This suggests there might be more restrictions on this habitable area. In particular, there might not be enough star formation in a galaxy's outer regions to generate the ingredients needed for rocky planets to form. Meanwhile, there are concerns about the inner regions, where stars are born and die more quickly. Regular supernovas in these areas could irradiate the surrounding space, raising the dangers for any possible life. New research suggests that the inner edge of the cosmic habitable zone may be farther from the galactic center than previously believed, which alters our concept of where life might truly flourish. What will the supernova, which we've nicknamed scarab juice, look like from Earth? It's unlikely that the biospheres on Earth will be affected, but it'll be impossible to miss the show. Experts reckon that scarab juice will stay bright for almost 90 days after it explodes. It'll be about half as bright as the moon and a lot less than a full moon. In other words, it'll be visible even during the day as a bright spot in the sky. Its incredible brightness, which even casts shadows at night, will delight everyone who looks up. The supernova will be visible with the naked eye for months, so it'll be a great way to get people's attention on Earth. While scarab juice's remnants will eventually fade, scientists are still studying it to learn more about the life cycle of massive stars and the processes that lead to their demise. It's important to understand these huge events to grasp how our galaxy evolved and how elements are created in a supernova. As well as visible light, the explosion produces a range of heavy materials, including uranium, silver, and gold, to replenish the interstellar medium with the building blocks needed for future star and planet formation. This process, which is called nucleosynthesis, is really important. It's worth mentioning that a supernova remnant can develop into a stellar nursery, where new stars are created from the gas and dust released after the explosion. This cyclical process shows how cosmic events are connected and how the death of one star can lead to the creation of others. Even long after the initial explosion, scientists have discovered a variety of supernova remnants that continue to create new stars, which goes to show just how dynamic the universe is. Another fascinating aspect of supernovae research is their role as cosmic distance indicators. White dwarf supernovae, which always reach their brightest, are used by astronomers as standard candles to measure cosmic distances. This approach has really helped us understand cosmic expansion and identify dark energy, which is this mysterious force that's responsible for the universe's rapid expansion. What's more, studying supernovae helps us understand whether exoplanets could support life. Scientists are looking at how planets orbiting nearby stars might be affected by the radiation released during these cosmic blasts, which could impact their atmospheres and the possibility of life. This study highlights how important it is to grasp the environmental factors that control life across the universe. There are fascinating considerations regarding how mankind may react to such cosmic events when a local supernova could be observed. Supernovae have influenced stories, folklore, and artistic creations throughout history. Not only is a star's explosion a scientific phenomenon, but it also has cultural significance as a symbol of transformation, devastation, and rebirth. Bright new stars in the night sky have been seen as signals or messages from the universe in many societies. In addition, technological developments have transformed our capacity to see and investigate supernovae. These events' structure and behavior can be revealed by taking detailed pictures and spectra of them using space telescopes fitted with state-of-the-art sensors. Additionally, ground-based observatories are essential for tracking fleeting occurrences because they enable astronomers to gather data in real time and react swiftly to observations. With the development of new telescopes and technologies, such as the James Webb Space Telescope, which promises to provide extraordinary insights into the life cycles of stars and the dynamics of their tragic deaths, the future of supernova study is full of intriguing possibilities. Our knowledge of star evolution and the basic mechanisms forming our cosmos may advance as a result of these discoveries. In conclusion, research on Betelgeuse and its upcoming supernova event opens up more general conversations on universal recycling, cosmic development, and the effects of these phenomena on life and culture. By shedding light on our position within this enormous, constantly shifting universe, research into such huge stars enhances our understanding of the complex and frequently violent cycles that govern it. Supernovae, which signal the end of a star's life and the subsequent creation of new celestial structures, are also important in the greater cosmic timeline. For instance, the leftover material may develop into nebulae, which are enormous gas and dust clouds that serve as ideal environments for the birth of new stars. Complex chemistry may exist in these areas, aiding in the formation of organic molecules, the building blocks of life. Furthermore, star formation in neighboring molecular clouds might be triggered by the shock waves generated by supernova explosions. This mechanism, called triggered star formation, illustrates how cosmic occurrences are interconnected and how a single sensitive event can initiate the production of new planetary systems and stars. This demonstrates the importance of supernovae as both endpoints and catalysts for further advancements in astronomy. In the larger context of the universe, supernovae also help disperse heavy elements across the cosmos, which enriches the material used to make future planets and stars, and ultimately affects the chemical diversity necessary for life. The significance of comprehending supernovae in the larger framework of astronomy, in the beginnings of the materials that comprise our own planet and life itself, is highlighted by this cosmic recycling.